So in this video, um, it's just supposed to be a reflection on the past few videos on stresses within thick-walled cylinders. Um, so there's just a few questions that kind of want you to go through. First off, what are the stresses? Stresses in thick-walled cylinders can be due to what types of applied loads. Um, so if there's no applied torque to the system, the three principal stresses in thick-walled cylinders are going to be what stresses. And then if these three stresses are going to correspond to the following equation. So I just expect you to look these up in like the previous parts of the lecture. Okay, so all the equations in this section are like equation 5.8 dash something. So please just write down the corresponding equation number in in this part here. In these different equations, they're going to be and a lot of the equations that we talked about today, they use these following variables. I think there's so many variables that were thrown at you during this lecture. It helps just to have one place where you just define what each of these variables mean. That way, when you're solving the problems, maybe in a couple of weeks, you can look back at um, this sheet and be like, oh, okay, that's what that variable means. All right. The last part is what equation should you use to determine P for a stress-filled cylinder? Again, it's going to be equation 5.8 dash something, right? Once you determine then once you have that interference pressure, what equations would you use to determine the stress, the radial stress and the tangential stress in your inner and outer cylinders? Okay, so just list those equations here, and go right ahead. All right, so I'm gonna um, so I recommend that you do right now is stop the video. All right, so stop the video. All right, and then in a few seconds here, I'm going to start and discuss the results of all these answers. But please answer the quizzes before you watch the rest of the video. It's much more intellectually engaging if you actually try them first and then check your answers instead of just copying down my responses. All right. So here are the answers to the reflection part of the lecture. The stresses in a thick-walled cylinder can be due to the internal pressure, the external pressure, or the rotational velocity. All right. In the case of if there's no externally applied torque, the three principal stresses in thick-walled cylinder problems are going to be sigma r, or your radial stress, sigma theta, your tangential stress, and sigma z, your stress along the length of the cylinder. Okay. Those three stresses correspond with the radial stress. It corresponds with equation 12. The tangential stress corresponds with equation 13, and the z stress corresponds to equation 16. Okay, all these equations are listed earlier in the lecture packet. All right, so you have lecture here 16, and 13 and 12. Okay. So the next part, which is to define the following variables. So you have the inner radius, the outer radius. Omega is the rotational velocity. Lowercase p, which corresponds to the pressure, where I would stand for internal, O would stand for external or outer. You have the modulus of elasticity for the inner element and the outer element. The Poisson's ratio for the inner and outer elements. And then you have the inner radius of the internal press fit element. Bi is the outer radius of the internal press fit element. BO is the inner radius of the external press fit element, and C is the outer radius of the press fit element. The only thing that's missing here, I recognize now, is delta, where delta is the interference, and delta would be equal to the BI minus BO. Okay? All right. And then the last parts were what equation should you use to determine the pressure for a press fit cylinder? You'd use equation 26. Once you have the pressure, how would you calculate sigma r and sigma theta? You'd use equations 12 for sigma r, and an equation 13 for 13, 19, or 21 for sigma theta, and then sigma 12 would, and the same thing, you use the same similar equations for the outer cylinder. You use equation 12, equation 13, but also you could use equation 22 and 20. So again, PI for the inner cylinder would be 0. The outer cylinder would be equal to the interference pressure, and pi would be equal for the inner cylinder would be equal to P, and the outer cylinder would be equal to 0. All right, external pressure. All right, so that concludes this recap on um, this reflection on the stresses due to external and internal pressures within thick wall pressure vessels.